Welcome to Biddle Crypto. Happy 2021. Today, I also have my buddy and co-host for the show, Matt.
Hi, this is Matt, your co-host for today with Tarun. Thanks for having me.
Before we begin, I would like to say a word about our sponsor, Liquid. AI applications, self-driving cars, Internet of Things, smart everything needs loads of data. An 8 GPU instance on AWS is still an expensive solution to lease or rent. Petabyte, exabyte, zettabyte, crazy byte. Future is data hungry and real time. So not all workloads are going to be on the cloud. On-prem workloads are here to stay. How to ensure proper utilization of your expensive on-prem hardware? That's where Liquid comes in. Liquid's innovative composable platform empowers data-driven startups and organizations to transform their static architecture into a dynamic one quickly, run heavy-duty AI workloads in the morning, and easily repurpose same hardware to run completely different workloads at night with just a few clicks. Configuration can be easily done at a bare metal server level in seconds. Learn more about them at liquid.com. It's liquid.com. For today's episode, we'll be talking to inventor of BitTorrent, Bram Cohen, about his new cryptocurrency startup, Chia. He's also joined by his co-founder, Gene Hoffman. Gene is equally accomplished. He's a former CEO of Vindicia and a co-founder of emusic. He also built and sold 3 companies to PGP, Vivendi, Universal, and AppDocs. You must be thinking that Bitcoin is at all-time high now in January of 2021, around $40,000 US. Then why do I need to listen to someone who's going to be redesigning cryptocurrency from ground up? To that, I say there are countless examples where progress happens when engineers and inventors improve upon their own inventions of others. For example, Edison's, Nikola Tesla's, and other countless examples in the world, even Ford's. Bram has such a credibility that he would have had no problems raising millions of dollars for his startup without even writing a single piece of code. But he didn't do that. He has been working on it for the last 5 years, conceptually and in code form. And he didn't go the ICO route where other people did, unlike many Silicon Valley marketers who boast about how much money they have raised. Bram believes in building first. I also like to call him Bram the Builder, obviously from Game of Thrones reference, as he has clearly chosen a road less traveled, a harder path. I can't tell you how much time I have spent on BitTorrent in my college days. His peer-to-peer protocol was widely used, is still widely used, and has inspired many Silicon Valley startups, to say the least. Another thing I would like to point out before this talk is his comments should not be taken as an attack on Bitcoin. He's a thinker, deep thinker, and a doer on a grand scale. And sometimes I've seen Bitcoin maximalists become very defensive. You just have to hear him out. What improvements he's suggesting and what he's working on. Yes, of course, he's taken some funding for initial round, but he's not a person who hasn't done the groundwork for creating this thing that he's creating. I even believe, this is my own personal opinion, is that if it wasn't Satoshi, it would have been Bram the builder. All right. So following is my conversation with him, the guy who's hailed by some as the world's best known network engineer, an expert with a beginner's mindset. Guys, here's Bram Cohen. So welcome to Biddle Crypto, Bram and Gene. We are really stoked to have you. Me and Matt are co-hosting this show, so we're really excited to have you on the show.
Thank you. And thanks for calling me a prodigy. I'm getting a little long in the tooth, so.
Okay, so I'm just going to dig in straight to the questions here. And so Bram, I've been a fan of yours ever since I discovered about you. So, in one of the interviews, you have mentioned that Bitcoin is a horrible, wonderful idea.
Yeah, I say it's Bitcoin is a wonderful, horrible idea, or maybe in the other order. It's from When the Grinch Stole Christmas. The Grinch had a wonderful, horrible idea of stealing Christmas. Bitcoin does what it claims. And the thing that it claims to do is seemingly impossible. Amazing technical feat using this I can't decide whether it's best to characterize it as a deep, profound insight or an incredibly cheap hack. It's probably both. But to understand what's going on here, you have to think about Bitcoin as a database. Bitcoin is a secure distributed database. Like literally, the people who are currently working on the database can disappear. They can go away. They can cease to exist. And other people can come in and start maintaining the database. And the database integrity will continue to remain intact. This is a really remarkable thing. It does this it's kind of this series of insights. Like the invention of Bitcoin didn't involve inventing any new cryptography, like at all. It's very old cryptography. To invent Bitcoin, you needed to invent the ecosystem around it. So Bitcoin, the basic idea, if we kind of think through how one would invent Bitcoin logically, the first question is like, well, how do you achieve consensus? And the answer is, well, there's going to be a weight proof. People are going to put blood, sweat, and tears into partial hash collisions. And those are going to sum up together in terms of their difficulty. And whichever version of the history has the greatest difficulty is going to win. That's how we're going to achieve consensus. If you and I get into an argument, we compare the weight of what we have locally. It's this very Marxist thing, actually, of the labor theory of value. We look at how much blood, sweat, and tears we have into what we have locally. And whoever has more, the other person says, oh, you must be right. And switches to that version as the consensus current state of the database. Then there's this question of, well, okay, how do we incentivize people to build on it? And the answer is, well, the database itself is going to mostly just keep track of this fungible item, these records, these amounts that are owned by someone. It's going to be money. And we're going to pay people to continue to build on this database using this money, that they're going to get rewards using that. And so those are the kind of deep insights. There are a bunch of other insights that are technical insights about how to work out the details that are actually done really weirdly well in Bitcoin. It really looks like, Satoshi had iterated on these ideas a couple of times before coming up with this thing, getting much more in the weeds. The deep insights are what I just said. Now the reason it's a horrible idea is that there are these follow-on questions of like, well, how much energy is this using up? Like, how wasteful is this? And how do you handle denial of service? And the answer to the first one is, well, it's just really, really wasteful. It burns a lot of electricity doing nothing. And the answer to the second one is, well, there's just a limit to the throughput because we want it to be possible for people to run full nodes. Which means that everything has to get copied everywhere. There's just going to be a pretty tight limit on the amount of transactions this thing can handle. It's going to be pretty small, and that's just the way it's going to be. So those are Bitcoin's limitations. But those caveats in place, Bitcoin absolutely does the basic thing it claims to do, which it is, in fact, a secure distributed database. And I have another rant about why this is an important thing as well.
I just want to say to our audience that Bram saying that it's a horrible, wonderful idea means what
as an engineer looking at, improving things. So he's improving, there are some Bitcoin maximalists and some of them now in India also, they're like, oh, don't say anything bad to Bitcoin. It's a very healthy argument to say like, hey, you know what, there are some improvements that put it out there in terms of like, because I've said that to my friends. Sometimes it's like, no, Bitcoin is like, the maximalist sort of approach or like, rules. It's a great invention. It has enabled cryptocurrencies. And I guess your project, which we're going to talk about further, improving upon it.
Yeah. So there is this tendency for people to just kind of internalize this and adopt this, extremely Marxist stance of, no, by definition, the value of Bitcoin is the amount of electricity that's been burned in mining it. It's like, no, that's silly. Like the value is in how valuable is achieving this consensus, not how much was wasted in it. This is like an old thing in economics that people who just sort of reinvent economics for themselves, including, Karl Marx, Ayn Rand, von Mises, who knew about the others, they all reinvent goldbugism, right? Which is all this central idea that the value of something is just how much did it cost to produce it. So this is, but much to my surprise, there's a bunch of things that we're doing that are still unique to us. Which I'm, very happy to evangelize about.
I have a question, Bram, Gene, which one thing you mentioned, right? These points about Bitcoin. At the same time, the incentives that lie outside of a system, for instance, miners, right? The miners who are able to control Bitcoin today can basically force their will upon the development or improvement of that network.
They sort of can. So there have been these battles in Bitcoin over how important are the miners. So miners are the help. They are paid to do a service. They do that service. They are not, inventing Bitcoin, and they are eminently replaceable. They are doing a commodity service here, something which is intentionally a commodity service. Miner centralization in Bitcoin is a very scary thing. If miners wanted to cause problems, more so for other miners than for Bitcoin proper, they could do some things that would be very, very destructive to the ecosystem, but make more money for themselves in the short term by orphaning other miners, right? Or possibly even, committing fraud on Bitcoin, where they, send Bitcoin in exchange for a wire transfer and then just reorg the chain to take the Bitcoin back again. Miners, for the most part, it appears to be don't do this. They could do this. It would be very easy for a small cabal of miners to go ahead and do this. It appears to be they mostly don't do it because it would do so much damage to the ecosystem that it would damage their sunk investment. That if you're a Bitcoin miner, you actually have a pretty substantial upfront investment in mining hardware and getting access to cheap electricity that you've probably prepaid for. And if you did damage to the value of Bitcoin, it would harm your future returns from this investment. And because of that, miners aren't, they would have to be in a point where it was worth it to them to basically exit scam the system. And they have enough money on the line that they don't want to do that. However, this depending so heavily on their incentives is kind of tenuous and scary. It would be better to not do this. So at Chia, we have this plan for a better way of doing things, which is, these criticisms are not new criticisms. They're kind of obvious criticisms. They're just in your face. This is what the system does. This is how it works. This is not a secret in any way, shape, or form. Although, for the most part, people try and fix it by going, oh, well, we'll switch to proof of stake. And that's actually a step backwards. Proof of stake was known before Bitcoin. It was worked on before Bitcoin. It was a bad idea then, still a bad idea now. And on top of a long list of highly technical issues, it has this fundamental problem that it's not really that decentralized of a system, that if everyone currently maintaining the database just disappears, in a proof of stake system, the database is toast. You need those people in the thing to come back again in order to move things forward. So that's making the problems in many ways worse. Now you have a cabal of people who have bonded rather than a cabal of people who have purchased mining hardware. But that said, Satoshi didn't make up mining for shits and giggles, right? Like I worked on Mojo Nation many years ago. which was, today you might call it a cryptocurrency. The way I like to phrase it is, if Ripple's a cryptocurrency, Mojo Nation was a cryptocurrency. But Mojo Nation made no pretense that the token server was anything other than just this centralized server. And the reason for that was mining hadn't been invented yet. It's like, the old Sesame Street cartoons where there's a bunch of cavemen talking about planning their day. And they're like, oh man, I'd like to do this, but cars haven't been invented yet. Mojo Nation was a glorious, amazing failure in no small part because it was just way, way too ahead of its time.
I remember you say that, it was a big failure, but it's good to have big failures.
If you're going to fail, you should fail that way. Right? Satoshi invented mining, and mining has these problems that are just in your face. We know what the problems are. It's not a secret, but it's hard to do something else. It's very difficult because in order for it to work, you need proofs of work that you do locally, right? And it turns out almost proofs of work boil down to electricity being burned. Like Satoshi was hoping this wouldn't be the case. In Satoshi's white paper, he says one CPU, one vote. He quite explicitly states that he thinks, and I think this held up for a while, that mining will mostly be done on general purpose CPUs, and most of the cost of mining will come from the amortized cost of manufacturing these CPUs in the first place, which is, probably how it worked for a little short period of time. But then people start building custom hardware and start industrializing it. And now, of course, we don't have one CPU, one vote at all. The costs of mining are completely dominated by manufacturing custom hardware and having access to the cheapest source of electricity, which totally dominate the thing. And it winds up being rather centralized. It's commodity replaceable, but it's a relatively small oligopoly for the most part on mining that's going on, which is not what you really want, and definitely not how Satoshi envisioned it. But the problem is you're constrained by what can you validate locally. You have this just technology problem. I want to be able to determine who wins. I need a type of proof of work that I can evaluate locally that will tell me the quality of this work that went into this thing. And the requirements of this thing, of this mathematical primitive you need, are quite onerous. It's something that's in some sense trivial if you have secure hash functions. You just look for partial collisions in your secure hash function. That's, for people who know, for cryptographers, this is like an incredibly obvious thing to use for proofs of work, is partial collisions in secure hash functions. If you don't have that, you've got a real problem on your hands, because you have all these requirements that it needs to follow. It needs to be, well, first off, that you can verify it, right, immediately. But it also needs to be that it has linear scaling, right? That there's no benefits, there's no economies of scale whatsoever from doing it. And it needs to be that successful results are completely anomalous. They sit nowhere near other successful results in the state space. There's probably a few other requirements that I'm not remembering off the top of my head, but those are kind of the big ones. And people have all kinds of proposals for doing other things. They talk about, just other ways of doing proof of work, which are just like whatever. It doesn't matter. It's just turns into a shit smoothie at some point of just throwing on other things other than SHA-2, add in like SHA-1 and some random bullshit that you made up, yada, yada. It's all kind of the same thing. All that really winds up doing is making it more expensive to build the mining hardware, which furthers the centralization of mining hardware production, which is a very bad thing. People have talked about making it ASIC resistant, which is kind of what that shit smoothie thing is about, trying to make it so that a general purpose CPU will do just as well as custom hardware for mining. It turns out this is basically a pipe dream. You just can't do it. There's just no way you could ever do it. You might get in within like an order of magnitude where you've still lost. And all you've really accomplished by doing this is make it so that there's yet even more centralization around mining hardware. And often centralization around mining in general, because often if there's something that's supposedly highly ASIC resistant, but someone manages to make custom hardware for it, they just don't tell anybody and they just do most of the mining themselves. And now you've got total centralization of there only being one entity who has this huge advantage and is pulling it off. Now, it's a really interesting technical problem to design ASIC resistant proof of work. That's a really fun thing to study.
For certain versions of the word fun.
Yeah, I think it's fun. It's in some sense not a good idea. Ideally, you want to get away from this burning of electricity that you have, because that's the whole goal of moving to a different type of proof of work or proof of work like thing. If you're not trying to get away from the electricity, you should just do the obvious thing of instead of trying to be ASIC resistant, you should be ASIC friendly. You should make it so that the hardware for doing mining is as cheap and commodity and low barrier to entry in terms of R&D for manufacturing it as it possibly can be. If you're going to do that, really, you should just iterate SHA-3 100 times as your proof of work and call it a day and not worry about it again. That's the way to go. I mean, you can fantasize about what you would like, right? Tony Lane Casserly, may she rest in peace, talked about like proof of knowledge. How can we make it so that there's a blockchain that's mined by human beings, where it's like CAPTCHA-fied, where the only way to move forward is have humans work on it, that's egalitarian and accessible to all humans. That sure would be nice.
Probably not practical or like.
Well, I mean, it's not going to produce proofs of work that can be automatically verified that have this topology of successful solutions that you want, right? Real world problems that humans are good at have approximate solutions, and good solutions that are very close to approximate solutions, right? And, actual human beings have very widely varying cognitive functions, and you have to really work on it hard to get something that can differentiate them well, especially things that can be checked in an automated manner. And then, also you have this like just pipe dream of making it so that the challenges that show up are useful ones, so people can post their useful problems to the blockchain. The problem there is someone can then find things that they know solutions to already and post those as the problems. And now they have an advantage over everybody else because they have better answers than other people do, because they, generated the problems for solutions that they already had available. And when people start trying to come up with fantasies of these things, the comparison I make is, would this be better than dick pic coin? Like, if you have a blockchain that's powered forward by dick pics that people post to it, this is a bad idea. However, it's a better idea than many of the useful proofs of work proposals that people have put forward. So that's kind of a benchmark of what's there.
Segues to the next question I have is, what is proof of space and time?
Right.
And it's, which Chia is based
so
on.
So that's what I was getting up to.
Yeah.
I'm interested in, I know you came up with this.
Yeah.
But is there a backstory? Was there some wild process that led to this moment?
4 years, I think. 4 years in the making.
Well, it was a long...
Maybe more like 5.
Oh, 5, yes.
It was a long thought process of coming up with ideas for it. And actually, we started Chia. At the time we started Chia, I had this plan for proofs of space and time, but VDFs hadn't actually been invented yet.
Can you explain VDFs?
Yeah. It's not important for that story, but I always tell people, don't have invent new math here on your product roadmap, which is good advice. I'm a total hypocrite.
We had it in 3 different places.
Yeah. I've gotten away with it here, but nobody else do it, please. It's a horrible idea. So you have these problems with finding an alternative to proof of work. You really, really have to thread the needle carefully. And so the question is, what is there in the world today which is completely commodity, which exists in mass quantities, which is completely commodity, where custom hardware will have no advantage, which is massively over-provisioned so that you're not wasting stuff by utilizing it? And there is an answer to this question, which is storage space. And actually, multiple people had this bright idea of hey, let's do proofs of space. So actually, a story about how I met Christoph, one of our advisors who basically me and him together invented our consensus algorithm. I gave a talk, Bitcoin devs here in San Francisco, talking about removing the waste from cryptocurrencies. And I talked about how this is basically a pipe dream. I went over the different approaches, how they're not a good idea. And at the end of it, I mentioned, well, for proof of space, if you take some ideas I had, some ideas some other people had, put them all in a blender, it might work.
This was 2015, by the way. So 2015.
Yeah. So by total coincidence, Christoph was sitting in the audience. Christoph was the advisor overseeing the Space Mint / Space Mesh project, which was an academic project trying to figure out how you could make a successful blockchain using proofs of space. So Christoph walks up to me after I'm done talking, and he says, "I think I know the proof of space algorithm you've come up with, and it's busted." And I was like, "Really?" He's like, "Yes." So he gave me some links. So multiple people invented the exact same thing, which is basically using rainbow tables, which is not completely trivial, but obvious enough. And it's subject to Hellman attacks. What in other contexts are called Hellman time-space trade-offs, here they're called attacks because you don't want them. In other places you do want them, here they're considered bad. So I was kind of bummed about this. And then I had an idea, a thought on this. And I later on explained it to Greg Maxwell, who immediately broke it just off the top of his head. And so I tweaked it off the top of my head. He broke it. We went back and forth a few times in one conversation. I'm like, okay, I'll think about it some more. So I thought about it some more, and then I ran into Greg again. And I gave him a tweaked version, and he broke it. We went back and forth a few times. I go, okay, I'll think about it some more. So third time, I ran him like, okay, here's where I'm at. And I gave him a thing. And Greg goes, okay, I can't break that anymore. I'm not saying it's secure. I don't think it's secure. I just can't break it anymore. That's all I'm saying. It's like, okay. So I then mailed Christoph about this. Oh, by the way, a bit of funny context. I dropped out of college. So my technical academic credentials are non-existent.
It doesn't matter. You've built stuff that I think academics haven't built. So.
Oh, yeah. Actually, my academic publishing history is very good because of there's the WalkSat paper, which was a thing I came up with when I was in high school, actually has a lot of citations in academia. So it's not like I'm an unknown quantity. And also there is a paper about BitTorrent that I wrote. But yes, Greg also, I believe, dropped out of college. Or actually, I think he dropped out of high school. I'm not sure about that. Anyway, so then I mailed Christoph, and Christoph had some conversation about what I was saying. And then so Christoph broke it. And I was like, okay, well, how about if we tweak it this way? And then Christoph broke it again. And I was like, okay, well, how about if we tweak it like this? And so Christoph looked at it, and he couldn't break it anymore, at least not off the top of his head. So he's like, okay, you know what? I'm just going to try and prove that this whole approach can't possibly work. And so he spent some time working on it with the help of, some of his colleagues, and came to the realization that he couldn't break it anymore because it's not breakable. So that's the origin story of our proof of space algorithm.
Yeah, so it seems like it's a lot of process back and forth. And for my listeners out there, you've been persistent on it, and for like years now. You're humble to say, hey, it was just a conversation, but it's over the years you've kind of refined it. You have the whole team working on it. So
right. Well, this is just part of it. I still haven't explained what VDFs are.
Right. Yes, I'm getting to that. I'm gonna first want our audience, since it's a little beginner friendly also show. I want first them to have a high level view of which I think you've gone in depth quite a bit of what proof of space and time is, as opposed to proof of work and proof of stake.
Okay. So explain the space part of it. That a proof of space is something where you have a plot, you have a pre-generated file. And because you pre-generated this file, when a challenge comes in, you are able to essentially act like your file is full of lottery tickets and have each one of them has some chance of successfully responding to this challenge, proportion to the amount of lottery tickets that you have.
So can you tell our audience? I know that what is a plot on a file that for our beginners, even people in engineering who are beginning, and people who are not particularly tied to databases.
Yeah. So that broken idea that I said, the one where Christoph says, I think I know what you came up with and it's broken. It's easiest to just explain that idea, because it has a really subtle break. It has a yet even more subtle fix. But in the end, you wind up back where you started. So it's easiest to just think in terms of the broken thing and just know that it's technically wrong, but all your intuitions about how the system works are correct from knowing this. So the broken thing is you have on your hard drive a whole bunch of public keys. So you pre-generated this. You generated a whole bunch of public keys, and you stored them on your hard drive, and then you sorted them. You put them in sorted order by like just their lexical hash value. Okay. So a challenge comes in, and the rule about the challenge is in order to successfully respond to this challenge, you need to very quickly generate a public key whose hash is very close to this challenge. That's the way this works. And because you sorted everything, you know where on the hard drive you have to look to find the thing, and you don't have to rescan the whole list. And so you get this like very low latency in response to challenges, which this whole process would be very slow if you hadn't sorted it in advance. That's, in a nutshell, kind of how proofs of space work, with the caveats that I just talked about at length.
I was going to say, as an end user, we have a minimum plot size, so you can kind of download a Windows or Mac installer, and you literally go plot. It'll take you somewhere between, on a really good machine, about 8 hours, and on a really slow machine, it can take you 20 hours, but it's usually in the 12-hour-ish range, and that creates you one plot, and that's 101 gig. And you're going to need somewhere between 10 and 20 to be really competitive early on, but this is how you kind of fill your hard drive space up in these
you have
100 gig increments.
You have a file that's called a plot file that basically contains these public keys, or you can pretend in your mind it does, even though that's technically not quite right. And so there's a process called plotting where you generate these files. It takes some amount of time to do. It has to take some amount of time because these files are, big enough that even just writing it out on your disk can take a while, depending on what type of storage media you have. But once you have the file, it's very, very fast to do these lookups. Just almost instantly, and almost no CPU is involved in doing them, even if this is a spinning disk, even if it's a physical hard drive.
I'm actually running a plot. I ran, and this is for everyone. Like I'm not super technical. I'm somewhat technical. So I am able to run a client. It's like BitTorrent. Back in the day, you just run a client and it does all of what Bram and Gene just told you guys. Is just doing it in the background. Nobody has to. Yeah, you have to monitor stuff and know a little bit about plotting and how, farming happens. But for the most part, it just runs in the background. It's just, I'm doing my video editing stuff and it runs in the background.
An important point is it will run on your machine while your machine is doing whatever else. Right. And you won't even notice it while it's doing that. The other part of that is we have UX, and I'm very glad that you've had a good experience running it, because, we're working on making our UX really nice and simple for this to really be a consumer internet application kind of a thing, not something that IT people are necessary to work on.
For everyone, I think it's something there.
Yeah, we want everybody to be able to download this no matter who they are, double click on it and say, okay, you can have my machine mostly between 11 p.m. and 6 a.m. and keep 5% of my hard drive open for me. But otherwise, make me as much money as you can.
Yeah. So I would like to explain proofs of time. Okay, so as an end user, you don't need to worry about the proofs of time, but they are happening there and they are important. So when you have proofs of space, they work in the sense of it doesn't require any real resources in order to make them. However, that's also kind of a detriment to the whole system, because you're worried about someone just making an alternative history and doing a 51% attack, even over a long range of time where the honest network might not have had a lot of resources back in the day. And because it doesn't cost any resources to build a blockchain, this is very trivial to do. So there's this question of how to stop this. And the answer is, I kind of think of it as being like work equals force times distance, right? That proof of space tells you the amount of force, right? And then you have these proofs of time, these things that are called verifiable delay functions that are the distance. So a VDF is a function where it requires a certain number of iterations to run, and you can't make it run faster. No matter how many machines you have ready to run in parallel, you can't make it run faster. However, it generates a very short proof in the end of the whole thing. So other people can say, oh yeah, that is in fact the correct answer to this question. And so what it winds up doing is alternating proofs of space and proofs of time, sort of. That the better a proof of space is, the more quickly it will show up, for the most part. And I'm glossing over things here.
It will need less iterations of proof of time.
Yeah. Again, we just rolled out our new consensus algorithm, which munges this quite a bit. But
the next layer down on the new consensus is a much more complicated conversation.
But
the higher level thought is enough.
That's kind of relatively speaking, the thought of how the whole thing works. And then there's all these different grinding attacks that you have to worry about, which have some very involved, subtle blockchain engineering to avoid, where you're really trying to make it so there's as little information as possible goes into challenges moving forward, so that when people are trying to make a blockchain that favors themselves, they have very little control over what challenges they're going to get in the process of making it. So a lot of subtle, interesting engineering work necessary to make that happen there. An interesting and important point, there's no direct incentive to run a VDF. It's kind of like running a full node. You're sort of doing a favor to everybody else. But the way VDFs work is it only takes like one honest person to be a spoiler and kind of ruin it for everybody. If people are trying to charge for VDF services or extort people for VDF services, anyone out there who has a fast enough VDF can just run their VDF on everything they get, and this ruins it for everybody. The blockchain's getting made, and other people can't gain advantage.
By fast enough VDF, you mean like the hardware required to run a
the iterations per second that it gets are pretty close.
Got it.
When we originally envisioned VDFs, we thought we'd kind of go from like the very tip end of the high-end Intel hardware and some of its acceleration capabilities to FPGAs and then to ASICs for this. It looks like our FPGA step isn't possible for the type of way we do our VDF. So we're now at a place where the very best hardware right now that's available to the general public is an i9 Bin 10 overclocked. However, some of the pre-release Intel hardware is out there at the major cloud hosting providers like Amazon and Google. And we actually saw one of them running a faster Time Lord and basically doing this, like preempting our fastest Time Lord in the world. So, it's very much an anybody can enter, anybody can go. And we expect to later help sponsor the kind of open sourcing of an ASIC for the Time Lord function, the VDF function, and making those available cheap and easy to anybody who wants to play with them. Because ultimately you want this calculation to be right up to kind of what the near theoretical hardware maximum speed is and no further. And you're just waiting for, the 9 nanometer process to speed it up later.
So Time Lord is related to VDF, and then the farming are related to the reward section, and the plotting is the actual proof of space and time done on
No. Farming is making the proofs of space. The Time Lord makes the proofs of time, and the plotting is what you do at the start or when you add more capacity to your farming.
Right.
You make a plot.
The Time Lord just sits there. It's a server that runs 3 VDFs at a time for various different reasons, and then kind of spits those out to the network, to the nodes, and gossip them all around to everybody.
And the VDFs alternating with that proof of space is what is protecting the network.
Yeah. So at a high level, what happens if someone joins today, right? And they're like, hey, I'm going to do basically a 51% attack, right? But I'm going to do it on the history, right? So I have a small fraction of all the capacity today, but much, much more capacity than was in the entire network a couple of years ago, because capacity's been going up exponentially, right? So they get this bright idea, oh, I know, I'll just redo history for a heavier chain than there is. And they can go ahead and do this, but because there are VDFs involved, if they are farming at their full capacity, they're only doing it at a certain rate. So they are making this alternative blockchain, which is heavier per time than the early days of the honest one. The problem for them is the honest chain, its peak is getting built on faster. More weight is getting added to it faster than this alternative historical chain than this person is making. So you can redo the last 10 years of farming with your capacity. The problem is it takes you 10 real wall clock years in order to do it, by which point, the honest chain will be much, much further ahead.
Super cool.
By the way, Time Lord was a reference from Doctor Who series, right? I watch it too, so I'm like a big fan. So I was like, oh, Time Lord.
Yeah.
So,
yeah. When you are farming, you don't need to worry about Time Lords. For the most part, they're just Time Lords out there that are helping you out. You don't have to worry about it.
Right. So Time Lord is somebody with the more improved hardware more like ASIC level sort of, configuration. And
well, you can try running a time lord yourself. The problem is it won't really find anything that it's because there's a much faster time lord out there, right?
Right.
So if you have a slower time lord, if you have slower hardware, you can run a time lord yourself. And what will happen is it's not really doing much. The fastest honest time lord is beating you to the punch every single time. But if that one goes offline and you're number 2, you immediately start winning right there.
And just give you a kind of sense of this, like a MacBook Pro that you bought today, pre M1, haven't run on M1, you'd get something like 150,000 iterations per second for RVDF. An unoverclocked i9 bin 10 will get you about 210,000 iterations per second. And an overclocked will get you into about 310,000 iterations per second. We saw 360 coming out of the new unreleased enterprise class Intel hardware because there's some neat optimizations that the new AVX 512 IFMA, extensions, give us. So
we assume that that's what it was. We don't really know for sure.
Yeah.
Somewhere
that's what's great about a blockchain.
What about the Ryzen's, the 5950s and, they have, 24 cores. They are also.
Yeah. So this is the weeds on how the VDF works. It multiplies 2 really large numbers together. And already the AVX extensions and the i9 speed it up compared to the AMD. It's basically taking 2 54-bit numbers and multiplying them as quickly as possible.
So no need of getting new Ryzen's. I mean, we're good with the i9.
For now, the Intel coming architecture that, I think we consumers will be able to get to spring or summer, right? It's just going to be as fast as is, humanly possible without creating custom hardware. Now, later, we're going to create that custom hardware and make it available for everybody.
Technically speaking, it doesn't actually spend most of its time in the multiplication part. It's in this other part where it's doing extended GCD, but that's also something where the IFMA instructions are very helpful.
But you can think of it as taking the time in the multiplication.
That went over my head.
But yeah, for people who want to understand what's going on, it's basically multiplying 2 very large numbers as quickly as possible to get a final outcome from a start of a known number. And there's only one path there, right? It always is going to be that if you iterate 10 million times, you get the same exact answer at the end. Right. And then the rest of the work is keeping it so that then you can prove it in like half a second that all of that 5 minutes went by.
Yeah, except that we're using binary quadratic forms instead of RSA groups.
For the complete nerds.
Good nuggets there from Bram, that's always good for my brain.
But we run the fastest that we know of, and then we run a couple backups on Amazon, and we'll make sure those are always there, and other people will too.